Vice Dean of the Dr. Al-Bara. She's the Vice Dean of the College of Medicine at Al Faisal University and the Chair of the Department of Family and Community Medicine. She is also Consultant of Family Medicine Physician at King Faisal Specialist Hospital and in the Research Center, and Adjunct Faculty Member at the University of Toronto. With over 20 years of experience, Dr. Al-Ghalayini has established herself as a leader in academia and clinical medicine. Dr. Al-Ghalayini is a Canadian board certified in family medicine with the College of Family Medicine of Canada, and she have brilliant achievements in founding the trainee TOT program in the SCF.
المعذرة بروف، راح نبدأ مع البروف أنيس كوبا حاليا، بعدين نروح للدكتورة براء.
Yeah, I know.
Yeah.
I'm just introducing both three panelists, Prof. Mazen, and then we will go.
الله يعطيك العافية.
She has also contributed as the co-learning lead of the Ministry Health VRO at Al Faisal University. She started the Center of Innovation and Partnership and Community Engagements, CIPC, at Al Faisal University, Faisal University Wellness and Health. And she is recognized with Faculty Award Research Excellency in 2024 and Health Equivalent Prevalence Care. She has published extensive topics such as chronic disease management, the impact of COVID-19 and health promotion. Dr. Al-Ghalayini is affiliated with the College of Family Medicine of Canada and Ontario Medical Association. Our second panelist will be Dr. Prof. Hani. He is a dedicated pediatric intensive with established background and caring for critically children. He hopes to excel a building relationship with teams and while achieving contributing to impact research. Prof. Tamish passions also and lies harnessing artificial AI, practically ChatGPT and large language model to enhance medical informatics simulations. And he works hard on educations and committed using his skills to benefit his patients, research, and institution, and eager to continue advancing the field of AI and healthcare. Prof. Mazen.
السلام عليكم. الله يعطيك العافية بروف. نبدأ إن شاء الله. أول سيشن، أول برزنتيشن إن شاء الله بتكون من دكتور بروف أنيس قوبعة. His topic is about AI replacing doctors, the revolution in digital healthcare transformation with large language models. Prof. Anis Qawba is a renowned figure in artificial intelligence and computer science, currently serving as the full professor at Al Faisal University College of Engineering and Advanced Computing. He has held significant leadership positions, including Director of Research and Initiative Center and Innovation Center at KSU. As aide to the President of Research Governance, he has been instrumental in enhancing the university's global standing. With over 2 decades of experience, Professor Qawba has made a substantial contribution to the field of AI, notably through development of the Arabic large language models series and various innovative projects in surveillance and computer vision. His work extends across multiple sectors such as healthcare, education, and human resources, implementing AI to drive business transformation. His expertise also covers robotics, drones, generative AI, and the Internet of Things, with significant applications in smart cities. A senior fellow of the Higher Education Academy in the UK, and an editor for over 20 Springer publications, Professor Qawba's contribution have placed him among the top 2% of scientists recognized by Stanford University. Please, Prof. Anis, you can start your presentation. Thank you.
السلام عليكم ورحمة الله وياكم. Okay.
عليكم السلام.
السلام ورحمة الله.
Are you able to see my screen?
Yes.
Okay. بسم الله الرحمن الرحيم والصلاة والسلام على نبينا محمد وعلى آله وصحبه أجمعين. Thank you very much for the invitation. I'm glad and delighted to be with you here today to contribute to the presentation on a very hot topic, which is the use of AI, or particularly the generative AI, large language models, into the healthcare sector. So my presentation is entitled, Will AI or is AI replacing doctors? And we're going to discuss the evolution of artificial intelligence and the different fields where AI has emerged in the healthcare sector, providing substantial services, either for doctors, for hospitals, or for patients. So let's get started by the strategic health sector objective of Saudi Arabia. So the kingdom is investing a lot. The healthcare sector has a particular importance in the strategic objectives by trying to provide better health, better care, and better healthcare sustainability in the kingdom by enhancing the public health through strengthening, for example, preventive care, and try to mitigate the impact of chronic disease and improving the lifestyle. Also, the kingdom is expanding the infrastructure by building more hospitals. So recently, 260 billion Saudi riyal were invested in building new hospitals here in the kingdom to ensure equal access across the regions. Also developing the healthcare workforce by building and training skilled medical professionals through targeted education and training programs. So now the question, how AI would help achieve these healthcare objectives. So AI actually is not something new in the healthcare sector. It's something that has been proposed since several years ago because AI was used to predict health risks, for example, and suggest early interventions. But what is changing now is the technology is becoming more and more mature. We have more powerful, intelligent machines that are able to provide more accurate services and results. Although through providing virtual assistance, for example, in the context of diet and exercise planning, the AI is able also to, in diagnosis, to detect chronic disease. Like I remember at the time of COVID-19, several researchers were working on the diagnosis of COVID-19 through X-rays and CT scans using advanced computer vision techniques for image classification. And now the current trend is also to use AI chatbots. The current chatbots that we see today, and I will show you some examples, are completely different from the old technology, which is based on very simple tree decision making. I think most of you have already had this kind of boring chatbots on WhatsApp where you have only a few choices. You cannot ask natural question. You cannot talk to the chatbot. It provides you some options. It's like navigating into an app bar or something similar. But now the chatbots, they are able to understand almost everything. They can understand any dialect. They can understand any language. You can talk to them naturally. And this actually provide an excellent opportunity to provide ubiquitous access to healthcare services to multiple persons. So the AI also can help in training, simulation for doctors, reduce paperwork, and there are a lot of business around this to how to reduce paperwork, streamline the healthcare transaction processes, and letting doctors focus more on care rather than on documentation or paperwork. So among AI now, generative AI is the trending, and maybe the boom started with the release of ChatGPT back in November 2022. And these large language models, they have huge capabilities that they are able to do almost everything related to text-based processing or image-based processing. And this has helped to improve the efficiency of administrative tasks, like, for example, automating the billing, the claim processing, and the scheduling appointments for patients. It helps also improve the clinical documentation by providing much accurate documentation much faster. It can generate treatment plans. It can generate patient education materials. It can provide recommendation for diagnosis. It can even improve existing doctor notes. And this has made a big transformation in the healthcare sector. So let me start. There are so many use cases, but I try to aggregate 2 or 3 use cases just to provide you a glimpse on the use of generative AI in the healthcare sector. I'm going to start by how AI is used to improve the clinical documentation, and also how we can use ambient listening to create automated documentation out of a conversation between a doctor and the patient. The features are real-time listening, so the AI system can capture the patient and provider or doctor interaction automatically. It can write clinical notes. It can generate automatic diagnosis that can help and speed up the writing of documentation upon a consultation. And it saves a lot of time. So I can show you one example. This is one example that we have developed with our industrial partners. Which is like we can have a device that records a conversation between a doctor and the patient. So you open the conversation, we can have a real-time transcription, which means converting the speech into a text instantly. And of course, when we make speech to text, there are always a lot of errors. If some people already did speech to text, we can have, but now with the use of generative AI, we are able to reconstruct the original transcript, even if the speech to text has huge errors. We are able to recover the original one. Okay, and after that, we are able to make AI clinical insights. I'm going to show you the big picture, showing this figure here, and extract the vital signs. Can integrate the data into the HIS systems. The AI can also recommend treatment plans, medication, and this is secure and efficient. Let me show you here clear this application. So we can start recording conversation between a doctor and the patient, and here we transcribe the speech, and finally we are able to extract the slices of speeches related to the doctor and to the patient. Because now the whole speech is going to be like one sequence. But with AI, we are able to decode what the doctor has said, and what the doctor has, and what the patient has said. And after this, we can have a clinical assessment report. This is automatically generated. Look, for example, here it's going to look at the conversation here. It detects كم درجة الحرارة, what is your temperature? It's 38. And now we can find automatically in a structured report the temperature is 38. Any other vital sign that is not part of the discussion, it's going to be here unavailable. There is also information about the blood pressure that was okay. تحتاج إلى ما وضعت الدم لديك 120 على 95. So it was detected, put in a structured way. It's quite impressive. And here it said, I'm going to give you paracetamol. Now we can find the current medication, paracetamol, and writing clinical notes, primary complaints. And so the nicest thing is that it's able even to know the ICD-10 codes and even the CPT code related to diagnosis and procedures. So this is quite impressive. Just by a natural conversation between the doctor and the patient, we are able to extract all this information instantly. Another service that also we work with our industrial partner is helping doctor to generate doctor notes. So here we provide a recommendation system, and after the doctor has written, for example, certain number of words, and taking into account the patient history and the clinical condition, we can generate, this is an automatically generated AI doctor note. So we can save a lot of time for the doctor, sometimes, especially for the first consultation, the doctor can spend maybe 10 minutes, 15 minutes writing a complete notes like this. Now we can make automated, and the doctor he can choose whether to accept this recommendation. He can try to write on his own word additional information, and based on this additional information, we can generate very accurate documentation for the doctor note. So these are some experiments we do now. We have also our some partners who work in the automating the approval of insurance claims. We know that many hospitals they suffer from high rejection. Sometimes there are missing information in the doctor note. Sometimes there are require more clarification for the diagnosis, for the treatment plan, for the procedure. So what we do, we take the doctor note, we take the patient history and several parameters, and we use the AI to review the doctor note, identify the gaps. So for example, if you look here, we can find what is in red here. There are some inconsistencies that are detected. So we can detect them in advance, and then we can improve the writing of the doctor note to be compliant with the insurance. And finally, we can also generate the claim that has to be sent to the insurance. So this actually can be easily done with artificial intelligence with large language models. Another use case is to use AI from neurolog and psychotherapy. And this particular sector is very critical because sometimes they deal with people with special conditions, special constraints. Sometimes these people don't want to express themselves because of social issues, because of so artificial intelligence here has solved a lot of these problems. It has been proven to be very accurate in analyzing mental health problems, okay, through virtual support with AI chatbots, real-time tracking, and also early detection. So one excellent and very recent research from 2025 is the use of large language model was proven to surpass human expert in predicting neuroscience results. And the authors here have proposed the brain bench, which is a test designed to test how well AI and human expert predict neuroscience findings. So they have considered 5 key research areas: behavioral, systems, disease, cellular development. And the research task is about compare 2 research abstract versions and identify the correct scientific results. And the decision process is based on human. They will read the both version and select the correct one based on their knowledge and confidence. And same thing for the LLM, it will use a metric called perplexity and choose a version that aligns better with the previous research pattern. So the key finding here is that they demonstrated that AI has consistently outperformed the human experts. So we can see, for example, here, there are different large language models with accuracies, and we can see the human level expert is it's at an average that is below the different type of large language model. This is human expert evaluation in terms of accuracy, and this is the variation among different other language models that were trained on neuroscience topics. And they discovered that compact model like Llama 7B also performed well as compared to large models. And this is an excellent study that shows the capabilities of artificial intelligence in providing mental health services in neuroscience field. Another also good contribution is the child counselor. And the purpose here is there is an LLM-based chatbot specialized in psychological counseling. This is one of the critical issues that psychotherapy doctors suffer from, because some of the patients they are shy to express themselves about their personal conditions, and they feel more comfortable to talk to a machine, okay, because of the social constraints, social issues, and so on. And here they have these researchers, they have trained this chatbot on authentic counseling conversations. So they have collected 260 counseling sessions, and they have fine-tuned ChatGPT model to act as a psychological counseling agent. And they employ advanced therapeutic techniques, And the impact is that it was able to bridge the gap between AI and mental health services. The AI was able to learn how to respond to a patient in the same way as doctors. So this is their methodology. They collected data, they processed with GPT-4, and then they fine-tuned the model. Fine-tune the model, it means they will train the model to mimic, okay, it's Vicuna 7B, using 8,000 dialogues among different sectors to be able to respond correctly to the query of the patients. And these are the main findings. Chat counselor was proven to be more specialized mental health. It was proven to be much better than non-trained AI models. Okay, it's almost as good as ChatGPT. Of course, here because they have trained a small model with only 7 billion parameters, whereas ChatGPT 4, it's 1.7 trillion parameters, much more expensive and difficult to deploy. So AI in mental health, there are many endeavors like using integrated devices for real-time monitoring of patients, continuous monitoring, and providing personalized care. Okay, so to conclude, also AI was used in the diagnosis and personalized medicine for early detection, for providing personalized plans and large-scale analysis. So one of our work when ChatGPT was released, we have used it to, we use here a simple classification algorithm for medical imaging. And then we use ChatGPT along with output of this medical image and the patient history, and we are able to generate automatic reports. Okay, so these are examples of automatic reports that are generated, and they were validated by doctors. So from a picture like this and the patient history, the large language model is able to generate automatically an accurate report providing all the different details. And this work was also done in collaboration with hospital doctors. Another thing is also to use AI in clinical trials and drug discovery. That's another topic, but now with large language model, it has improved a lot. The drug discovery process we can use large databases to train LLMs. This will save cost because, of course, hospital doctors know that this process is very tedious. It requires a lot of clinical trials, validations, certifications, and other requirements. And one nice paper recently proposed, 2005, this was like last month, is that they discovered that hallucination of large language model, they can improve the drug discovery. And the idea here, okay, yeah, the hallucination can improve the drug discovery. The new idea is that AI generates unexpected molecular insights beyond traditional perspective that even expert would not think about it. And this reveals potential molecule uses previously overlooked by the scientists. So this is maybe one of the first papers that I have seen that hallucination would have a positive impact on certain fields. So they have to find better pattern recognition, and they are able to enhance the learning from data. So this is the paper if you are interested to dig more into the details. And the idea here is that step one is that AI describes a molecule. The AI will get a molecule code and turns it into word, and sometimes add extra details that are not 100% correct. And the second step is that AI will predict if it fights HAV, for example. If AI reads from its own description, it answers yes or no, and the added detail help AI to make better guesses. Of course, there are still challenges on the use of artificial intelligence in healthcare, including data privacy, cybersecurity attacks. This is why everybody is motivated about AI, but you know the integration is still slower than the pace of the discoveries in the AI integration with the healthcare.
Excuse me, bro.
Yes,
only 1 minute remaining. Yeah.
Okay, yeah, I finished my presentation. This is just concluding slides. So the challenges in healthcare AI implementation, there is a risk of data bias. But now with the evolution of large language models, this is actually less less problematic. But the most important handicaps is that the regulatory gaps, because now using language model like ChatGPT, many people care about data privacy, data security, data breaches, and so on. But with the evolution of open source LLM models, it's possible now to have a fully deployed, a fully local deployed solution on premises without having to go for third-party requests. So overcoming the AI implementation hurdles, ensure AI training data represent all population to reduce the bias. The scale of the data is really important. Okay, there is also a need to collaborate with regulatory collaboration, not to have any issues, and also provide education program. The best thing to reduce the gap between professionals and AI is to train them to understand this technology, how it works. They must know about their limitations. Otherwise, it's going to be always reluctance about the adoption. Okay, so thank you very much. It was a pleasure giving you this presentation. I'll be happy to hear from you if you have any questions.
Thank you very much, Prof. Anis, for this very beautiful presentation. Unfortunately, we don't have time now for Q&As. However, we do have a networking session at 10 for this current session. You can meet with Prof. Anis at that time. Thank you very much, Prof. Anis. Our next speaker is Dr. Bara Al-Ghalayini. Her topic is about AI and SDOH moving forward, moving towards or away from health equity. Prof. Dr. Al-Ghalayini is not available to give her presentation. However, we do have a recording of her presentation, which will be starting now. Thank you.
بسم الله الرحمن الرحيم والصلاة والسلام على سيدنا محمد خاتم الأنبياء والمرسلين. My name is Bara Al-Ghalayini. I'm very pleased to present to you today about on a topic titled AI and the social determinants of health, moving towards or away from health equity. I have no conflict of interest to declare, but I need to declare that I am a family physician by background. I'm not a data scientist. I will not be discussing a lot of details related to from the AI perspective. Rather, I'll be basically sharing my experience as a healthcare practitioner and lessons learned while I was preparing for this talk and from my general practice. So I think this important is really important, and what I would expect to this talk to cover and from the audience to hopefully learn about is first of all to know what do I mean by the social determinants of health and why is it important, and how to have this sense of awareness and perception about it in our daily practices. Also, understand and appreciate health equity and why is it important to learn about health equity and health disparities. How AI can help in promoting health equity, and what are the implicit bias that is AI related that would sway us away from health equity. So let's start by defining the social determinants of health. So as per the WHO definition, the SDOH are defined as the conditions in which people are born, grow, live, work, and age. The determinants of health include social and economic environment, as well as the physical environment, person's individual characteristics and behaviors. The Association of Faculty of Medicine of Canada defined the SDOH as the explanations for broad patterns of disease in a whole group of people. The determinants exert their effect through the individual's risk factors, and this was basically known as the causes of the causes, which is a very sort of comprehensive and basically a unique definition of the determinants of health. And so what is the link between the social determinants of health and health outcomes? Well, Less favorable health outcome, which we call healthcare disparities, refer to differences in health outcomes between groups, often due to social, economic, and systemic factors. And so the systemic inequalities, like AI-related implicit bias, are important factors that affect health disparities through the determinants of health. Meaning AI leads to the AI inherited implicit bias leads to health disparities, and we'll share with you how in the next slide. And so the AI tools that the biased AI algorithm can lead to discriminatory outcomes affecting patient access to care and treatment decisions and overall health outcomes. But before digging more into the disparities and the AI-related bias, let's discuss some useful AI health implications. And I would like to start by the AI tools developed to analyze retinal scans in diabetic retinopathy, which is really commonly used across the world. One of the very successful projects is the tool, the project explored and identified by Dr. Salwa Al-Hazza in treating and screening for diabetic retinopathy in our local population. The AI-powered telemedicine platforms is another example. These platforms provide virtual consultations, monitor chronic conditions, and predict health risks based on patient data. Also, AI-driven platforms that prevent medication errors by flagging potential drug interactions or inappropriate prescriptions, as well as AI-powered chatbots to provides basically mental health support, give responses that are cognitive behavioral therapy based, and suggest some coping strategies, which provide an excellent basically tool to access to patients who don't really have access to and can't afford mental health counseling and or seeing a psychiatrist. And so the biased, as I said, biased AI algorithm can lead to discriminatory outcomes affecting patient access to care, treatment decision, as well as an overall health outcome. But how does this happen? I mean, this basically happened through the biased AI algorithm, as the AI, as I said, implicit bias can the AI system trained on biased data sets may amplify existing healthcare inequalities, particularly affecting historically disadvantaged groups. Also, biased AI can result in a misdiagnosis or inappropriate treatment recommendation, potentially causing harm to patients. AI systems may incorrectly prioritize health resources, leading to some patients receiving inadequate care while others receive unnecessary interventions. Also, the black box, which is which basically happen as naturally in some of the AI algorithms, make it difficult to identify and address biases, raising concerns about accountability and trust in healthcare decision making. And finally, the use of large data to train AI systems raises really highly concerns about the confidentiality and privacy of how these data being accessed, how is it being obtained, and how is it being managed. Let's give some more detailed examples of AI-related biases. So basically, the oxygen saturation detection during the COVID pandemic, the oximeter, some of the oximeters that were used, particularly in UK and even globally, they were found to overestimate oxygen levels in non-white patients, potentially delaying hospitalization. For patients for those who needs it, and delivery of oxygen treatment for those individuals. This bias in a widely used medical device could have had serious consequences for patient care. Cancer detection, specifically talking about skin cancer detection, technologies have been found to be less accurate for darker skinned people, potentially leading to delayed diagnosis and treatment for these populations. The genetic testing using polygenic risk scores is based on data sets overwhelmingly drawn from population of European ancestry and basically in the UK Biobank, for example, 94% of the participants are classified as white, while only 1.6 are Black and 1.6 South Asian. This lack of diversity in genetic data can lead to less accurate predictions for non-European populations. One of the studies revealed that the US and Chinese data sets and authors were disproportionately overrepresented in clinical AI research, potentially leading to biased algorithm that may not be generalizable well enough to other populations. What else do we know? The surgical AI systems in robotic surgeries. One of the studies involving robotic surgeries and from 3 different hospitals, and these were different countries, found that AI models assessing surgical skills exhibited bias, showing different rates of underskilling or overskilling across surgeon subcohorts. So basically, it depends on how the needle was moving. They were evaluating the skills of the surgeons based on the move of the needles and how it was programmed, rather than the actual skills of the surgeons. And of course, the gender bias in cardiac care. Female patients are disproportionately misdiagnosed for heart disease and eventually receive insufficient or incorrect treatment. These examples demonstrate that AI bias in healthcare is a global issue, affecting various aspects of medical care and potentially exacerbating existing health inequities across different populations and countries. But do different cultures perceive AI-driven bias differently? Well, the answer is yes. Different cultures interpret AI bias in healthcare through diverse lenses, influences by their social narrative landscapes and degrees of trust in medical institutions. Let's give some examples. So, for instance, African Americans and other minority groups in the US often exhibit higher levels of medical mistrust, which extends to AI-driven healthcare decisions. This mistrust is rooted in historical discrimination and can lead to skepticism about the fitness or the fairness, of AI systems in healthcare. Another example is the indigenous populations may view AI healthcare tools with caution, especially when these tools fail to account for the unique cultural practices and dietary habits. For example, an AI-driven diabetes management app for indigenous communities faced challenges due to its initial lack of cultural sensitivity. Also, immigrants' population in diverse countries like the US or Canada may perceive AI bias through the lens of language barriers and cultural differences. There is growing concern about AI-driven language translation tools and diagnostic systems potentially perpetuating healthcare disparities among these groups. What about non-Western cultures? So non-Western cultures may be more likely to have their symptoms misinterpreted by AI systems, as these tools often attribute reported symptoms to traditional beliefs or practices rather than considering medical explanations. And so basically they don't really disclose these symptoms to their doctors, and probably their doctors, they fail to report them or document them in their records. And so now that we covered basically touch base on the cultural differences among the perception of AI-related biases, let's talk a bit about where do these biases stem from. So basically, talking about gender bias, the underrepresentation of women in clinical trials can result in AI models that perform poorly for female patients, especially in areas like cardiovascular disease diagnosis. BMI bias also. Over-reliance on BMI in AI systems can lead to inaccurate health assessment, particularly for minority populations. As basically BMI really fail to accurately differentiate between muscle and fat. This critical oversight often leads, like for example, to athletes and others with substantial muscle mass being misclassified as overweight or obese, while individuals with seemingly normal BMI may harbor hidden health risks due to elevated body fat. Also, BMI fails to consider essential factors such as age, sex, and ethnicity, which play significant role in body composition and health. What about underrepresentative training data? So AI models trained on data sets that lack diversity or overrepresent certain population, for example, those in European descent, may not accurately reflect health risk faced by minority groups. The historical inequalities that exist, biases and the existing biases in healthcare, such as underdiagnosis of cardiovascular disease in women, we mentioned earlier, are reflected and sometimes amplified in AI algorithms. The flawed proxy measures using metrics like healthcare spending as proxies for health needs can definitely disadvantage groups who can not really access healthcare. For example, those who are uninsured or homeless people, or like in the US, the Black or African Americans. Also, the developer assumptions play a role, as biases can be introduced through the assumption made by AI developers about symptoms prevalence in different demographic groups. This is why, as we alluded earlier, the researchers and the study centers needs to be situated globally and not just centered in high-income countries such as the US. And finally, algorithmic opacity. We mentioned the black box nature of some AI algorithms, particularly those using deep learning, makes it difficult to identify and address biases. And so, to make AI more impactful for diverse population, it is vital to focus on building technologies, infrastructure in regions that currently lack data. And by prioritizing thorough external validation and calibration of models before their clinical implementation, their effectiveness can be enhanced and ensure they address the need of broader patient population and help promote health equity. And so basically, what are some of these solutions, and how can healthcare institutes identify and address AI bias through several key strategies? First is to establish a comprehensive and reliable data collection practices that ensure accuracy and integrity at every stage. Employ advanced bias detection tools specifically designed to uncover hidden prejudice and in data and algorithms. Integrate fairness-aware algorithms that prioritize equitable outcomes for all users. Create and implement continuous monitoring protocols that guarantee ongoing assessment and adjustment. Champion transparency and accountability by openly sharing processes, methodologies, and results with stakeholders and the public. Engage in ongoing research and evaluation to stay at the forefront of emerging issues and best practices in fairness and equity. And finally, provide immersive training and diversity and cultural competency to equip healthcare providers with the knowledge and skills necessary to effectively address the determinants of health. And with this, I would like to really move to the lessons learned. These lessons I learned really myself, and I believe learning about this topic is quite crucial. And I believe the fact that being aware that AI-related biases or how it affects health differs across culture was quite an eye-opener for myself. And I would really like to collaborate with colleagues from across different disciplines into creating a tool, a training tool for and specifically interprofessional tool that can be applied on different healthcare sectors, whether it's a curriculum, whether it's a continuous professional development tool that, first of all, to raise awareness to that important topic, and to help practitioners to recognize their personal biases and to start documenting the social determinants of health. First, to be aware of it, to document it so it becomes reflected in the electronic medical records, and hopefully that will create a better data sets and will train a better algorithms to pick up those cues that will eventually lead into better health equity and minimize health disparities. This is my email, so please, anyone who's interested, please feel free to drop me a line or send me an email, and we'll be happy to connect and collaborate. These are my references, and thank you so much.
All thanks to Dr. Al-Bara for this informative presentation. And we're going next for our last panelist for this panel. Prof. Hani Timsah, he's going to talk about building agile multidisciplinary research teams for AI computational medicine, strategies for rapid collaboration. We're anxious to hear from you, Prof. Timsah.
Thank you very much. Thank you. You can see my slides and hear me well, please, just to confirm.
Yeah, it's clear.
Okay. So I will try my best to catch up on time. So hopefully this is one of the topics. First of all, I would really like to thank the organizing committee for the kind invitation and for this awesome opportunity for us as a multidisciplinary to meet together. I think this is the fourth version of this conference. This is the mean streamlining multidisciplinary approach. So when I thought about this, I said I'd start with this picture that really shows how I look at AI as a frenemy. So he is our friend, and also we shouldn't see he or she. It could be our enemy also at the same time. But without going much into the time, I just want to emphasize, and I will go with you through a quick journey about the same topic about this. Each word, I will take it into a slide. Hopefully that will make some fun learning and experience for all of us. As a disclaimer, I have no conflicts to declare. And I have utilized the O1 model of ChatGPT to back and forth discussion. Actually, I use it as a multidisciplinary, I wouldn't say a colleague, so a tool in this approach, trying to build up these slides for all of us. So let's start with the word building. Building is defined as the systematic creation and foundation laying for a successful project or team. Obviously, I know I'm just putting obvious things there, but I just want to have a deep reflection, because I believe the multidisciplinary team, when you want to establish it, it has to go personalized to each project and to each team. So building a team, it's always need to have established clear vision of the AI in the computational medicine project, securing the leadership and the team members. So when in that building phase, it sets the tone for the subsequent collaboration. Going to the agile. So the agile, by definition, it's a flexibility, the responsiveness to change, and it's commonly used in the software development, but it's becoming more increasingly used in research. And surely the agile component is very crucial when we are talking about something that's changing very rapidly. So implementing short cycles with a rapid learning and rapid cycles that go back to the beginning to be adapted to the unexpected challenges that we have seen dramatically in the last couple of years. We have seen how AI is rapidly changing. I'm talking especially focusing when we are talking about the generative AI, which became so much accessible to almost everyone on Earth. So how to adopt an agile principle in our research, and probably many of you have seen that maybe you are working on some AI-related project and the team, and you are you are in the middle of the project already. Someone else has published a paper on it or a preprint with almost similar to what you have been working on. Multidisciplinary, again, it's indicating the collaboration across multiple fields. We are talking about in here referring as a medicine, computer science. I'm from the medical background, so I'm very honored whenever I learn and I interact with colleagues from the computer science, from the data engineering. The biostatistician always has been very insightful in my career. So leveraging these diverse skills sets for the innovation, and for us as researchers, we look for innovation, and we ensure that all relevant perspectives, including the clinical, technical, ethical, are considered to combine them towards fostering a creativity and practically leading to a robust real-world solutions in computational medicine. So this is what we are looking for. And this is one of the interesting papers that I looked for. I wanted to see, I don't want to prove it for us, but at least does multidisciplinary research gives really effect. And I found this interesting paper. It's I think it's more than almost like 15 years, this paper, and it's already has around 600 citations. So if any one of you wanted to read it, you can take a screenshot. And basically what it says that the science of team science encompasses an amalgam of conceptual and methodologic strategies aimed at understanding and enhancing the outcomes of large-scale collaborative research and training programs. I found it very nicely written. So if anyone, it's a lengthy paper, but if you want to go through it. So what are the benefits that we may get from our research? Again, the research, what does it refer to? It's the systematic inquiry aimed at discovering new knowledge or interpreting existing data through the AI methods or into the AI field by itself. So we are trying to generate the novel insights and ensuring the reproducibility and scientific rigor, and getting a solid research methodology is the backbone of any AI-driven project to ensure we have a credible and impactful publications eventually. Our teams, so they are the human resources core, and they are the comprising the individuals with complementary skills working towards a shared goal, and they are accountable for that goal. If you remember, at some stage when the ChatGPT initially came, there was some publication, They put the author at ChatGPT as an author, which was later on withdrawn, because you need a team who is accountable. You need the humans there. So this is very important to remember to foster open communication and define clear roles for each one of your team members. Getting effective team dynamics really accelerates the problem solving and helps avoid common project pitfalls if we do it properly. If things are vague, it really it just hinders. It takes more time, and eventually that multidisciplinary project unfortunately it may not go to full publication. So please, we have to keep in mind, and you are aware, we are keeping in mind about our teams. The word for, I don't want to even miss the simple word. So in this context, it indicates a purpose and the direction, why the work is being done. So always we have to remember about having a goal-oriented approach, which is clear, defined according to the systematic way, and outlined desired outcomes such as improved diagnosis, personalized treatment or management, or cost savings. So always we need the why behind the project. It's what drives the motivation of your whole team. So that's very important to keep in mind. The AI, again, you are the AI experts, so we have been using it, but it's the capability of machines to mimic the cognitive functions and learning skills of us as humans. So we have to specify the AI techniques relevant to our domain. Are we focusing on the machine learning, deep learning, NLP? And again, this is your domains, and to assess the data requirements and how ethically and they are being done and according to the laws. So choosing the right AI methodology is a key to have different teams reach their goals. The word N, again, we are talking about AI in computational medicine, which implies real-world applications and integration within medical workflows. So the focus on the practical healthcare applications, ensuring the integration with existing clinical IT systems, and AI must seamlessly integrate into medical environments to be effective, requiring domain-specific designs. Computational, again, this is your field, and you are the champions here. So it emphasizes the algorithmic and data-driven nature of the work in medicine, modeling, simulation, big data analysis, and we are trying to the word leverage. And I'm sure all of you have noticed how much we are using the word leverage with the AI since it came. So the word to leverage robust computational pipelines and cloud infrastructure to maintain data integrity and efficiency in handling large-scale data sets, to have so we have efficient computation underlying fast and iterative experimentation, which is critical for our rapid progress. Medicine, again, we are talking about the clinical context, diagnosing, treating, preventing illness with a patient-centric focus. Remember, there is medicine, the traditional, there is medicine also the something non-traditional medicine. So just to keep in mind, so we have to align our AI solutions with the clinical needs of our society to drive better patient outcomes, and while respecting patient data privacy and being a patient advocate, with the clinical relevance is paramount to have these AI tools or AI research solve real painful points in our healthcare, how to improve it, how to have better utilization at efficient cost. Strategies, they are planned methods or approaches to achieve the project overarching goals. So we need always to have a clear focused roadmap, which we may revisit during our execution of our project, just to make sure the plan is clear for all our team members and stakeholders, to implement the best practices for the data governance and project management. And this thoughtful strategies will have our efforts much easier to be done, reducing the risk and increasing the project success outcomes. Okay, again, another 4. Remember, this is another 4 in our title. So we are highlighting the purposeful actions needed to enable our rapid collaboration, So we have always to see what's the best mechanism for your own unique structure. So even for us, a structured team, multidisciplinary team. So even if you have, I'm a researcher in team A, it could be different, different perspective how I collaborate in team B. So how you do your real-time collaboration to make it fast and efficient, aiming also always for transparency among our team from the beginning and throughout the process, and to keep a constant communication open to maintain the project healthy and on the momentum. Going with the word rapid, which is the keystone in my slides, hopefully. So we need the high speed, necessitating the lean processes, committed time frame, and minimal bureaucracy. And this shortened the feedback cycles with weekly or even sometimes bi-weekly meetings, enabling the decision-making agility and empowering this speed matters. So as much as possible, again, in Arabic, it's man sabaq labaq, always. So it's very crucial with this rapid evolution of our AI, and always maintain the collaboration spirit. So it's the act of working jointly. So remember, team leader is not the team owner. He is just there to ensure the collaboration is mutual, it's respectful, and empowering each of our colleagues, encouraging the open knowledge sharing, communication channels, as we mentioned, and having effective collaboration as the glue that holds this multidisciplinary team. And believe me, and you have seen that once you have one successful collaboration, again, you will have your multidisciplinary team goes into another research adventure. So putting it all together, I hope I'm in time. Previously, I was using my multidisciplinary approach to go for a 6 months doable project. However, currently with this AI driven research powers that are globally, I sometimes find that I need to go with the 6 weeks plan. So going from the foundation and scope, going to the next month, data preparation and initial modeling, iteration and collaboration. These are just pure hypothetical frameworks, going to a validation and analysis, going to optimization and finalization. Again, these are just drafted with the ChatGPT OpenAI. I just wanted to put them as an example, and I'm sure each one of you has an excellent example that may be shared in the breakout rooms. And then until you reach your submission and dissemination, always keep in mind with this rapid progress, put a preprint if possible, so you can establish that you were the first one to pioneer this research before the others, because sometimes we have seen high time being required now by the peer reviewed and high rejections or taking months. So go for, you have seen probably how many mid archives are there. In conclusion, I just want to make sure we are embracing the agile methodologies to remain adaptable, the multidisciplinary buy-in with a regularly validate, and with the clinical experts to ensure the medical applicability. So always the data scientists, the expert biostatisticians, the healthcare providers, the patients as stakeholders, or the community, even if they are not patient, the individuals, these are very important component of the team, making sure we are compliant with our laws, bylaws, SADAIA, our ethical standards, with the IRB, both nationally and international laws like the HIPAA or the European GDPR. We have to make sure we have continuous improvement to use every result as a feedback for the next level. And by following these steps and focusing on the agile multidisciplinary team, you will be reaching and maintaining high scientific rigor and clinical relevance. I hope I did not take much of the time. And
No, Prof. Hani, you have time. You have time.
Oh, okay. So I tried my best. I was speeding up, so sorry for that speed, but my slides will be available through Prof. Asma. If anyone would like to share them at later on, they are all at your disposal. Thank you, Prof.
Thank